Hello, in this lecture we'll find out the maximum area of a rectangle that is inside a triangle. In the drawing we have triangle ABC. Side AB of this triangle ABC equals to 10 units in its length. Side AC equals to 17 units in its length. This is side BC, that's equal to 21 units in its length. Inside this triangle ABC, we have this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. So, in the first step, we'll do a construction, that is to say, from point A, we'll go perpendicular on side PQ. Again, from point A, we'll go perpendicular on side PQ. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A and PQ as M. In the next step, we will extend the perpendicular AM by a straight line until it touches side TS. Again, we will extend the perpendicular AM by a straight line until it touches side TS. And we will define the touching point of the extended perpendicular AM with side TS. This point is point N. So, here, by doing this construction, we created here two corresponding angles. Angle AMQ, that is the right angle, is the first corresponding angle, and the second angle is angle ANS, that is also a corresponding angle. And those two corresponding angles, they are located between the parallel lines PQ and TS, and therefore they are equal to each other. Why side PQ is parallel to side TS? Because of the fact that PQST is a rectangle, and you know that the opposite sides of a rectangle are parallel to each other. So those two angles, they are located between the parallel lines PQ and TS, and therefore they are equal to each other. But this angle AMQ is a right angle, therefore this angle ANS, must be also equal to 90 degrees in its size. According to the rule that corresponding angles between parallel lines are equal to each other. Likewise, we have here those two angles, that is to say angle AMP, and this is angle ANT. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and TS, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction. Therefore, this angle must be also equal to 90 degrees in its size. In the next step, we'll focus on the right triangle A and B. This is the right triangle A and B. And we'll define this side BN as X. BN equals to X according to our definition. So, if BN equals to X, then what is the length of side NC? From the drawing it is very easy to see that NC will be equal in total to BC minus BN. Again, BC minus BN equals to NC. So I write it down. NC equals to BC minus BN. So NC equals to BC, BC equals to 21 units in its length according to what is given as the question, minus Bn, Bn equals to x according to our definition, therefore in total NC equals to 21 minus x. So this is line 7 NC, this actually equals to 21 minus x units in its length. So in the next step, we continue to focus on this right triangle A and this is the right triangle A and B. This is the letter is B. So this is the right triangle A and B. So I copy this right triangle A and B in a new page, and we will implement the Pythagoras theorem on this right triangle A and B. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse AB of the right triangle A and B equals to 10 units in its length according to what is given as the question. Side AN equals to x according to our definition, and AN is the missing side. So actually, this is the right triangle ABN that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle ABN, the square of the hypotenuse is AB squared. And it must be equal to Bn squared plus An squared. This is equation 1. So according to the Pythagoras theorem, in the right triangle ABN, AB squared equals to Bn squared plus An squared. Here we subtract Bn squared from this equation 1. And again, according to equation 1, this equation 1, An squared equals to AB squared minus Bn squared. So An is the missing side, so we leave it as it is. So An squared, according to equation 1, An squared equals to AB squared. The hypotenuse AB equals to 10, therefore AB squared is 10 squared, that is 100, minus Bn squared. Bn is x, therefore Bn squared is x squared. So according to equation 1, we actually found out that An squared equals to 100 minus x squared. In the next step, I'll copy this right triangle A and C in a new page, and we implement on this triangle also the Pythagoras theorem. Again, by PT here is a abbreviation for Pythagoras theorem. side NC of the right triangle ANC equals to 21 minus x units in its length. Side AN is unknown. And the hypotenuse AC in the right triangle ANC equals to 17 units in its length. So actually, this is the right triangle ANC, the curvature of the original drawing. In this right triangle ANC, according to the Pythagoras theorem, AC square equals to NC square plus AN square. So write it down. This will be equation 2. So according to equation 2, in the right triangle ANC, AC square, that is the square of the hypotenuse, equals to NC square plus AN square. So here we subtract NC square from this equation. And finally we get that according to this equation, equation 2, AN square equals to AC square minus NC square. So according to this equation, equation 2, AN square equals to AC square. AC equals to 17, therefore AC square is 17 square, that is 289, minus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So actually, according to equation 2, we found out that AN square equals to 289 minus 21 minus x square. This is according to equation 2, and according to equation 1, we have already found out that AN square equals to 100 minus x square. So here two equations for AN square. In the next step, we create equation 3 that states that AN square, according to equation 1, must be equal to AN square according to equation 2. So AN square according to equation 1 is 100 minus x square, and it must be equal to AN square according to equation 2. AN square according to equation 2 equals to 289 minus 21 minus x square. So according to equation 3, we actually found out that 100 minus x square equals to 289 minus 21 minus x square. So here we'll open the brackets of this expression and we get that according to this equation, equation 3, 100 minus x squared equals to 289. And here we have minus, and 21 minus x squared equals to 21 squared, that is 441 minus plus x squared minus 2 times 21 times x is minus 42x. We check again that 21 squared indeed equals to 441. Okay, so according to equation 3, 100 minus x squared equals to 289 minus 441 plus x squared minus 42x. So here we'll open the brackets this side of the equation 3, and we get that according to equation 3, 100 minus x squared equals to 289, and here we have minus before the bracket, so it will be minus 441, and here we have minus x squared, and here minus times minus is plus, so it is plus 42x. So here we have x squared on both sides of the equation, equation 3, so x squared will get cancelled. After cancelled, we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After we cancel minus x squared, find out that according to this equation, equation 3, in this side of the equation 3, we have 100 is equals to 289 minus 441 plus 42x. Here we will add 441 to this equation, equation 3. And we get that according to this equation, equation 3, 441 plus 100 equals to 541. This equals to 289 plus 42x. So here we subtract 289 from this equation, equation 3. And we get that according to this equation, equation 3, 541 minus 289 equals to 252. So 252 equals to 42x. Here we divide this equation, equation 3, by 42. And finally we get that according to this equation, equation 3, x equals to 252 over 42 is 6. So x equals to 6 units in its length. That is to say, here we have in the original drawing here we have side line segment BN equals to x, so x equals to 6. That is to say, line segment BN that equals to x equals to 6 units. And here we have line segment NC that is equals to 21 minus x, and x is 6, so and x is 6, so 21 minus x is 21 minus 6, that is 15. According to equation 1, repeat again, according to equation 1, we found out that an squared equals to 100 minus x squared. Now we substitute x by 6, and we get that an squared, because x equals to 6, so an squared equals to 100 minus x squared. X is 6, therefore x squared is 6 squared, that is 36. So an squared equals to 100 minus 36, that is 64. An squared equals to 64. We'll take a root out of this equation, and finally we get that an equals to the square root of 64, that is 8. So here, this is the side an, and it is equals to 6 units in its length. an equals to 8. Again, an equals to 8 units in its length. AN equals to 8. So here we have those two angles. They are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because they are equal to each other. So this angle is alpha, and this angle also equals to alpha according to the rule that I mentioned. Likewise, those two angles are also defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if we define this angle as beta, then this angle must be also equal to beta because they are equal to each other according to the rules that I mentioned. The corresponding angles between parallel lines are equal to each other. So in the next step, we define the width of rectangle PQST, the width of this rectangle, the width QS is B. So QS equals to B units in its length according to our definition. And we define the width, the length of this rectangle PQST as A. That is to say, PQ equals to A units in its length according to our definition. PQ equals to A. The width QS equals to B, and the length PQ of this rectangle PQST equals to A, also according to our definition. In the next step, we'll focus on this quadrilateral MQSN. First of all, this angle equals to 90 degrees, and this angle also equals to 90 degrees because of the fact that it is given as the question that PQST is a rectangle. You know that all the four angles inside any rectangle are right angles. Those two angles are the two angles that are the angles in rectangle PQST, and all the angles in rectangle PQST are right angles, and therefore those two angles are right angles. So in the next step, we'll focus on the small quadrilateral MQSN. In this small quadrilateral MQSN, this is the small quadrilateral MQSN. Inside this quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the fourth missing angle, this fourth missing angle, must be equal to 90 degrees in size. So inside this quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this small quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle MQSN, side QS must be equal to the opposite side MN. But QS equals to B, therefore MN must be also equal to B. We found out that AN equals to 8. AN equals to 8, therefore AEM equals to AN minus MN. Again, AEM AM equals to AN minus MN. So AM equals to AN is 8, minus MN is B. So in total, AM equals to 8 minus B. Here, AM equals to 8 minus B. So, in the next step, we prove that the small triangle APQ, this is the small triangle APQ, that this small triangle APQ is similar to the big triangle ABC. So, why those two triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, this is a common angle, it belongs to both triangles. Therefore, this angle A equals to itself, it's a common angle that belongs to both triangles. So we actually proved that all the three angles in the big triangle ABC are correspondingly equal to all the three angles of the small triangle APQ. Therefore, those two triangles are similar to each other according to angle similarity rule. So I write it down. We actually proved that the big triangle ABC is similar. This is the sign of similar to the small triangle APQ according to angle similarity rule. And we know that in similar triangles, the ratio between the heights of a similar triangles are equal to the ratio between the sides. Again, in the similar triangles, the ratio between the heights is equal to the ratio between the sides. And therefore, the height AM of the small triangle APQ over the height AN of the big triangle ABC must be equal to side PQ of the small triangle APQ over side BC of the big triangle ABC. Repeat again. According to the rule that the heights in any similar triangles are equal to the ratio between the heights of a similar triangle is equal to the ratio between the sides. We get that AM over AN equals to PQ over BC. AM equals to 8 minus B. Yeah. AM equals to 8 minus B. So we substitute AM by 8 minus B over AN. AN equals to 8. AN equals to 8. We substitute AN by 8. And it is equals to PQ. PQ, according to our definition, equals to A, that is the length of rectangle PQST. So PQ is A over BC. BC, according to what is given as the equation, equals to 21 units in its length. So in conclusion, we found out that 8 over b over 8 minus b over 8 equals to 8 over 21. Here we cross multiply this equation and we get that 8a equals to 21 times 8 minus b. This is equation 1. So here we divide this equation 1 by 8. Finally we get that according to this equation 1, a equals to 21 over 8 times a minus b. Repeat again. According to equation 1, we actually found out that a is the length of this rectangle PQST. So a is equals to 21 over 8 times 8 minus b. So here we open the brackets on this side of this equation 1, and you get that according to this equation 1, a equals to, here we have 21 times 8 over 8 is 21, and here we have 21 over 8 times minus b is 21, is minus 21 over 8 times b. So in conclusion, according to equation 1, we actually found out that a, the length a of rectangle PQST is equals to 21 minus 21 over 8 times b. So here we multiply this equation 1 by b, and finally we get that a times b. Here, a times b is the width, b times a is the length. The width times the length is the area of this rectangle PQST, and that is the area that we are looking for. So a times b is the area of the rectangle. Here we have to multiply this side also by b. So 21 times b is 21b, and we have here minus 21 over 8 times b equals to minus 21 over 8 b squared. So we found out that the area of the rectangle, that is to say a times b, equals to 21b minus 21 over 8 times b squared. So we have the area of the rectangle in terms of b. b is the independent variable, and the area is the dependent variable. I repeat again that our mission in this question is to find out the maximum area of this rectangle PQST. So in order to find out the maximum area of this rectangle PQST, so this is the function for the area. The area of rectangle PQST, that is to say a times b, equals to 21 times b minus 21 over 8 times b squared. So the independent variable is b. So actually our mission is to find out the maximum value of this function, with this 21b minus 21 over 8 times b squared. In order to find out the maximum, so what is the value of b that gives us the maximum value of this expression, that is actually the area of rectangle PQST. Okay, so in order to find out the maximum extreme point of this rectangle PQST, we will differentiate the function, and then we will equate the derivative to 0. So first of all, we will differentiate this function. That is to say, we will take the derivative of this function. So the function is 21b minus 21 over 8. That is the function of the area of the rectangle. This is minus 21 over 8 times b squared. So we'll differentiate the area function according to the variable that is b. B is the variable, the independent variable. So, and then we will equate differentiate the derivative of this function, of this area function, to 0. So the derivative equals to 0 in order to find out the extreme points of this area function. Okay, so the derivative of 21b minus 21 over 8 times b squared. What is the derivative of 21b? The derivative of 21b is of course 21. And here we have minus 21 over 8 times b squared. What is the derivative of b squared? The derivative of b squared is of course equals to 2b. So actually this is the derivative of the original function, that is the area function, that is to say the function of the area is 21b minus 21 over 8 b squared. And in the next step, as I already mentioned, that we will equate the derivative of this function area to 0 in order to find out the extreme point of this function. So the derivative equals to 0. Now we find out the extreme points of this function. So first of all, we take 21 as a common factor from these expressions. So 21 is a common factor. What is left from 21 after we took from it 21 as a common factor? What is left is actually 1. And here we have this expression, minus 21 over 8 times 2b. What is left from this expression after we took from it 21 as a common factor? What is left is actually minus 2 over 8 times b. And it is equals to 0. So here we divide this equation by 21. Here 21 over 21 is 1, so 21 will get cancelled. And in this side of the equation we're left with 1 minus 2 eighths times b, and is equals to 0 over 21 is 0. So here we add minus 2b over 8 to this equation, and finally we get that 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression. We divide both the numerator and the denominator of this expression by 2, and we get that 1 equals to 2b over 2 is b, and 8 over 2 is 4. So in total we actually found out that 1 equals to b over 4. Here we multiply this equation by 4, and finally we get that b equals to 4 units in its length. That is to say, when the value of the width b is equal to 4 units, when the width is equal to 4 units in its length, then the area of rectangle PQST is in its extreme, point. So it might be minimum extreme point, or it might be also, it could be also maximum extreme point. So now we have to verify that when b equals to 4, the area of this, when the width b equals to 4, this is the width 3, the width b is equals to 4 units in itself, then the area of this rectangle PQST is in its maximum value. So in order to verify that we got a maximum extreme point and not minimum extreme point, I actually draw the function of the area. Actually, this is the area function of the rectangle. In the y-axis we have the area, in the x-axis we have the width b. So you can see here that when b equals to 4 units, then the area is in its maximum value. Therefore, we actually found out that the extreme point b equals to 4 is a maximum extreme point and not a minimum extreme point, and therefore that is actually the answer to the question. Now we'll find out what is the value of the area of this rectangle PQST when the width b equals to 4 units in itself. You can see it from here, but we'll find out directly from the function itself. So the area function, that is today a times b, that is the area of this rectangle PQST, is equals to, the area is a times b, of course, the width times the length, or the length times the width, and it is equals to, actually to 21b minus 21 over 8 b squared. So this is the area function of rectangle PQST, when b is the width and a is the length. Now we'll put the value of b, we'll substitute b by 4 in order to find out the area of this, the maximum area of this rectangle PQST. And we get that the maximum area of this rectangle PQST, maximum area of rectangle PQST, is equals to 21 times b, and b is 4, so it is 21 times 4 minus 21 over 8. b is 4, therefore b squared is 16. So the area equals to 21 times 4, that is 84, minus here we have 16 over 8, that is 2, and 2 times minus 21 is minus 42. So the maximum area of this rectangle PQST is equals to 24 minus 42, that is 42. That is to say, when the width of this rectangle PQST is equals to 4 units, and the length, that is a, is equals to 10.5 units, then the maximum area will be 10 times 2.5, that is 42 square units. And therefore the maximum area of this rectangle PQST is equals to 42 units in its length. Okay, so in the next step I will summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside this triangle ABC. So in addition, we know that side AB equals to 10 units in its length, triangle ABC, side AC equals to 17 units in its length, and this is side BC, that's equal to 21 units in its length. Repeat again that our mission is to find out the maximum area of this rectangle PQST. So in the first step we did a construction, that is to say from point A we do perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point SM. In the next step we extended the perpendicular AM by straight line until it touches side TS. And we define the touching point of the extended perpendicular AM and side TS, this point SN. So here, those two angles, they are defined as corresponding angles and they are located between the parallel lines PQ and TS. Why PQ is parallel to TS? Because of the fact that PQTS is a rectangle, and we know that the opposite sides of a rectangle are parallel to each other. So those two corresponding angles are located between those two parallel lines and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees in its size. Likewise, those two angles are also defined as corresponding angles and they are located between the two parallel lines PQ and TS and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees because they are equal to each other. Okay? So in the next step we define the length of line segment BN as X. So what is the length of side and of line segment NC? From the drawing it is very easy to see that NC in total equals to BC minus BN. Again, NC equals to BC minus BN. Repeat again. Here we have NC equals to BC minus BN. So NC equals to BC, that is 21, minus BN, that is X according to our definition. So in total, we actually found out that this line segment NC equals to 21 minus X units in its length. In the next step, I copied this right triangle A and B in a new page and implemented the paradox theorem in this right triangle, triangle A and B. Actually, this is the right triangle, triangle A and B. This is the right triangle, triangle A and B that are copied from the original drawing. It is given us a question that the hypotenuse AB equals to 10 units in its length. AN is unknown and BN equals to X units in its length according to our definition. So in this right triangle ABN, according to the Pythagoras theorem, AB square equals to BN square plus AN square. AB is 10, therefore B square is 10 square. But before that, actually, we did it later. So according to equation 1, we actually found out that here we subtracted BN square from this equation, equation 1. We found out that AN square equals to AB square minus BN square. This is according to equation 1. I repeat again. But AN is the missing side, so AN square, we leave it as it is. And it is equal to AB square. AB is 10, therefore AB square is 10 squared, that is 100. Minus BN square. BN is X, therefore BN square is X square. So in total, actually, according to equation 1, we found out that AN square equals to 100 minus X square. This is according to equation 1. In the next step, I copied this right triangle, triangle A and C in a new page and implemented the Pythagoras theorem on this right triangle A and C. This is the right triangle A and C that I copied from the original drawing. In this right triangle A and C, it is given us the equation that the hypotenuse AC equals to 17 units in its length. We already found out that NC equals to 21 minus X units in its length, and AN is the unknown. The side AN is unknown. So according to the Pythagoras theorem, in this right triangle A and C, AC square equals to NC square plus AN square. Again, AC square equals to NC square plus AN square. Here we subtracted NC square from this equation, and finally found out that according to this equation, equation 2, AN square equals to AC square minus NC square. Repeat again, according to equation 2, we actually found out that AN square, according to equation 2, we actually found out that AN square equals to AC square minus AC square. AN square is unknown, and it is equal to AC square. AC is 17, therefore AC square is 17 squared, that is 289, minus NC square. NC is 21 minus X, therefore NC square is 21 minus X squared. So, in conclusion, according to equation 2, we actually found out that AN square equals to 289 minus 21 minus X squared. This is according to equation 2, while according to equation 1, we have already found out that AN square equals to 100 minus X squared. So we have two equations for AN square. Therefore, we created equation 3 that says that AN square according to equation 1 must be equal to AN square according to equation 2. AN square according to equation 1 equals to 100 minus X squared. And it must be equal to AN square according to equation 2, that is equal to 289 minus 21 minus X squared. So according to equation 3, we actually found out that 100 minus X squared equals to 289 minus 21 minus X squared. Here we open the brackets of this expression and found out that according to equation 3, 100 minus X squared equals to 289, and here we have minus, and in the brackets we have 21 minus X squared. 21 minus X squared equals to 21 squared, that is 441, plus X squared, minus 2 times 21 times X, that is minus 42X. Here we open the brackets of this expression and found out actually that according to this equation 3, 100 minus X squared equals to 289, and after we open the brackets, this will be minus 441 minus X squared, and minus times minus is plus. Minus 42X equals to minus 42X equals to plus 42X. So here we have X squared on both sides of the equation, so X squared we have minus X squared on both sides of the equation, so minus X squared will get cancelled. After cancelled minus X squared, in this side of the equation we left only with 100. On the other side of the equation we left with 289 minus 441 plus 42X. I repeat again, according to equation 3, we actually found out that 100 equals to 289 minus 441 plus 42X. Here we added 42X to this equation, equation 3, and finally found out that according to this equation, equation 3, 100 plus 441 equals to 541. In this side of the equation we have only 541. In the other side of the equation we left with 289 plus 42X. Here we subtract 289 from this equation, equation 3, and finally found out that 541 minus 289 equals to 252. So in this side of the equation we left only with 252, and 252 equals to 42X. Here we divided this equation, equation 3, by 42, and finally found out that X equals to 252 over 42. 252 over 42 is 6. So we found out that X equals to 6 units in its length. That is to say, the length of this line segment BN is equal to X is equals to 6 units. And here we have the length of this line segment NC equals to 21 minus X. But X is 6, therefore 21 minus X is 21 minus 6, that is 15. In the next step, we return to equation 1. According to equation 1, we found out that AN squared equals to 100 minus X squared. Okay, so AN squared equals to 100, and we just right now found out that X equals to 6. If X equals to 6, it means that X squared equals to 6 squared, that is 36. So in total, AN squared equals to 100 minus X squared. It means that AN squared equals to 100 minus 36. 100 minus 36 is 64. So an squared equals to 64. We took out of this equation and finally found out that an equals to the square root of 64, that is 8. So this line segment an equals to 8 units in its length. Here an equals to 8 units in its length. In the next step, we focus on those two angles. Those two angles are defined as corresponding angles and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because they are equal to each other. Likewise, we focus on these two angles. Those two angles are also defined as corresponding angles and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So if this angle is beta, then this angle must be also equal to beta because they are equal to each other. In the next step, we proved that the right big triangle ABC is similar to the right, no, the triangle ABC is not the right triangle. The big triangle ABC is similar to the small triangle APQ. So why those two triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle is a common angle that belongs to both triangles. So this angle equals to itself as a common angle that belongs to both triangles. So we shall prove that all the three angles in the big right triangle ABC are correspondingly equal to all those three angles in the small triangle AQN, and therefore those two right triangles are similar to each other according to angle similarity rule. I repeat again, the big triangle ABC is similar, this is the sign of similar, to the small triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between the heights of the two similar triangles must be equal to the ratio between their sides. Again, the ratio between the heights must be equal to the ratio between the sides of two similar triangles. Therefore, the height AM of the small triangle over the height AN of the big triangle must be equal to side PQ of the small triangle over side BC of the big triangle. Again, because of the fact that the big triangle ABC is similar to the small triangle APQ, the ratio between the heights of those two similar triangles must be equal to the ratio between the sides. The ratio between the heights is AM over AN, and the ratio between the sides is PQ over BC. So in conclusion, we found out that AM over AN equals to PQ over BC. AM equals to 8 minus B. So we substitute AM by 8 minus B. AN over AN. AN equals to 8. So we substitute AN by 8. And it is equal to PQ. PQ, actually we defined the length of rectangle PQ ST SA and the width QS as B. Therefore, the length PQ equals to A according to our definition over BC. BC equals to 21 units according to what is given as the question. So in total we shall find out that 8 minus B over 8 equals to A over 21. Here of course multiply this equation and finally found out that 8A equals to 21 times 8 minus B. This is according to equation 1. Here we divided this equation 1 by 8. And finally found out that A equals to 21 over 8 times 8 minus B. Repeat again. After we divided this equation 1 by 8, we found out that A, that is the length of this rectangle PQST, is equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation 1 and finally found out that A equals to, here we have 8 in the numerator and 8 in the denominator, so 8 will get cancelled and we left only with 21. And here we have 21 over 8 times minus B, that is 21 over 8, that is minus 21 over 8 times B. So here we multiply this equation 1 by B and found out that in this side of equation 1 we have A times B. A is the length of this rectangle PQST, and B is the width of this rectangle PQST. Therefore, the length times the width is equal to the area of this rectangle PQST. That is the area that we are looking for. So A times B is the area of this rectangle PQST. And here we have to multiply this side of the equation by B. 21 times B is 21B, and minus 21 over 8B times B equals to minus 21 over 8B squared. Okay, so here we actually found out that the function area of this rectangle PQST is actually A times B. The area equals to 21B minus 21.8 times B squared. So the area is dependent on the width B. And our mission is to find out the maximum area of this rectangle. That is to say, our mission is to find out the maximum area of this function. That's actually the function area of rectangle PQST. In order to find out the maximum of this function, we have to differentiate this function, and then we will have to equate the derivative to 0. In this way, we will find out the extreme points of this function. The extreme point could be a minimum extreme point, but it also could be maximum extreme point. Okay, so actually we differentiate this area function, that is to say the derivative of this function 21b minus 21 over 8b squared according to the variable d. So, and we equate this derivative to 0. So what is the derivative of 21b? The derivative of 21b is of course 21, because the derivative of b is 1. So the derivative of 21b is 21. And we have here the derivative of minus 21 over 8 b squared times b squared. So the derivative of b squared is 2b. So in total, this expression, after we differentiate it, will be equal to minus 21 over 8 times 2b, because the derivative of b squared is 2b. So in conclusion, we should found out that the derivative of the function area 21b minus 21 over 8b squared, the derivative equals to 21 minus 21 over 8 times 2b. Now we have to equate the derivative to 0 in order to find out extreme points in this area function. So we equated this derivative to 0. Here we took 21 as a common factor from those two expressions. So here 21 was taken out as a common factor. What is left from 21? We took from it 21 as a common factor. What is left is actually 1. And here we have this expression. We took from it 21 as a common factor. So what is left from minus 21 over 8 times 2b after we took from it 21 as a common factor? What is left is actually minus 2b over 8. And it equals to 0. So here we divided this equation by 21. So here 21 over 21 is 1. So 21 we get cancelled. And we left in this side of the equation only with 1 minus 2b over 8. On the other side of the equation we have 0. 0 over 21 is 0. So in conclusion, according to this equation, we found out that 1 minus 2hb equals to 0. Here we had 2hb to this equation, and we found out that 1 equals to 2hb. Here we divided this expression, both the numerator and the denominator, by 2. 2b over 2 is b, and 8 over 2 is 4. So in conclusion, we found out that 1 equals to b over 4. We will multiply this equation by 4 and finally found out that b equals to 4 units in its length. This is to say, when the width b of this rectangle PQST is equals to 4 units in its length, then the area function has an extreme point. Okay? But we don't know whether if the extreme point is a maximum extreme point or a minimum extreme point. In order to verify that when b equals to 4, the extreme point is a maximum extreme point and not minimum extreme point, actually draw the area function. This is the area function of this rectangle PQST. In the y-axis we have the area. In the x-axis we have b, that is the width. B is the variable that is independent variable, and here the area is dependent on the value of b. And you can definitely see that when b equals to 4 units in its length, that is to say, when the width of this rectangle PQST is equals to 4 units in its length, here QS this is equals to b is equals to 4 units in its length, then the area of this rectangle PQST is its maximum value, because here this is the maximum value of the area. And therefore, we actually found out that the point b equals to 4 is the maximum point and not a minimum point. And therefore, that's actually the answer to the question. When b equals to 4 units, when the width equals to 4 units in its length, then the value of the area function is its maximum value. Now we'll find out what is the value of this area function when the width b equals to 4. We can see it from the drawing itself, but we also do the calculation from the area function. And the area function of this rectangle PQST, actually this function is equals to AB is the area function, because AB is the area of this rectangle PQST, and it is equals to 21b minus 21 over 8 times b squared. And we already found out that the maximum value of this area function, we get the maximum value when the width b equals to 4. Now we'll substitute b by 4 in order to find out the maximum area of this rectangle PQST. So we substitute b by 4. And found out that the maximum area of this rectangle PQST equals to 21b, and b is 4, so it is 21 times 4 times, we have here 21 over 8 times b squared. B is 4, therefore b squared is 4 squared, that is 16. So the maximum area of rectangle PQST equals to 21 times 4, that is 84. And here we have 16 over 8 is 2, and 2 times 21 is 42. So in total, we actually found out that the maximum area of this rectangle PQST equals to 84 minus 22, that is 84 minus 42, that is 42. So the maximum area of this rectangle PQST is equals to 42 square units, and in this case the width of this rectangle PQST, that is to say QS, that is equal to B equals to 4 units in itself, and the length PQ, that is A, is equal to 10.5 units in itself, and the length A, that is 10.5 units times the width B, 10.5 times 4 is 42 square units. So the maximum area of this rectangle PQST that is located inside this triangle ABC is equals to 42 square units. Okay, thank you very much.